In this video, we're going to complete a really short question on electric field strength and potential. Pause the video now and try the question. Electric field strength, the definition of this is standard and you must know it. Sometimes it is 2 marks because there are 2 parts to it. It is the force per unit positive charge. So it is from this relationship here, force per charge, but it's always defined the direction a positive charge will move. Part I, show the maximum charge that can be stored on the sphere is this. So what information have we got? We've been given a radius of a sphere and we've been given an electric field strength. So this is very simply, it's the relationship between charge and electric field strength. So sometimes, there's a lot of equations that look very similar, but it's this one here. Electric field strength is given by charge divided by 4 pi epsilon naught r squared. So this is showing how the electric field spreads out in space. The electric field does depend on 1 over r squared, and it does depend on the charge because it's the electric field due to a single charge. So we're saying, how does this charge here, how does its field spread out in space? And if you think in terms of that, it does help us, select the right equation and understand why it's r squared and why it's q and not r or not qq. So plug in all the numbers. We've been given electric field strength, microcoulombs, 12.5 times 10 to the minus 6 coulombs, and radius, that's 25 times 10 to the minus 2 meters. And then it's simply a case of rearranging and saying Q is E times 4 pi epsilon naught r squared. Plug in all the numbers and you get 12.5 microcoulombs, or 12.5 times 10 to the minus 6 coulombs, which is obviously what we've been asked to show here. And then part II, calculate the potential of the sphere for this maximum charge. So the equation for potential, V potential, is given by Q over 4 pi epsilon naught R. So there is a difference here. This is the potential due to a charge, so similar to this, but it varies with 1 over R, not 1 over R squared. So the potential drops at a much slower rate than the electric field, and sometimes we say that the electric field is the gradient, or the inverse gradient of the potential. So again, we're plugging in the numbers, we're plugging in charge. You could always answer it using this value even if you didn't do the first part. R is obviously the same here. Plug in the numbers and you get 4.5 times 10 to the 5 volts.